every session, as you know. Um, right. Okay. Now it's recording. I think. So suppose you have this vector x that contains these four numbers, 3, 22, 5, and 7. And then using the rep command, right, you can repeat it as many times as you want. So for example, if you say rep x comma times equal to 2, it will repeat it 2 times. So you get this. So 322, 57, 322, 57. If you say if you say times equal to 3, it will repeat it 3 times. So 322, 57, 322, 57, 322, 57, and so on. Now, if you say something like this, yeah, then it will repeat the first element 1 time and repeat the second element 2 times, and the third 2 times, and the fourth 3 times. So you get this output: 3, 22, 22, 5, 5, 7, 7, 7. Right? And there's also a command called length out. Length out is just it gives you the length of the output. So here 8 means that the length of the output must be 8. So x is repeated enough times so that the length of the output is 8. So if you suppose you change this to 12, now the length of the output is 12. So you get this 322, 57, 322, 57, 322, 57, right, and so on. Okay, guys. Okay. Now, if you have any questions, just feel free to use the chat box. All right, I will answer them as soon as I can. Right. Okay. The next thing is each. There's a command called each. So that means you're repeating each element of the vector. Right. So here, each element is repeated 2 times. So 3, 3, 22, 22, 5, 5, 7, 7. Okay. Okay. Now, this means 1:3 means all the numbers from 1 to 3. So if you do something like this, 1:3, then times 2, you will get this. So you get the numbers 1 to 3 repeated 2 times, right? John, yeah, it doesn't need to be a multiple, John. It doesn't need to be the multiple of the original vector. So for example, I think that's a good question. You should go back to this, right? And suppose you enter 5, right? Length out to be 5. Then here you will get 322, 573. Suppose you enter 6, it will be 322, 57, 322, and so on, right? Okay, now let's go back to this. If you say each equal to 2, it will give you this output. So each element is repeated 2 times, 1, 1, 2, 2, 3, 3. And if you say times vector from 1 to 3, then here 1 is repeated 1 time, 2 is repeated 2 times, and 3 is repeated 3 times. And the rep can also be applied when you have non-numeric, like letters, for example. Suppose you have a vector with 2 letters A and B, excuse me, right? And you want to repeat the letter A 2 times and the letter B 3 times, and this is what you will get, right? So A is repeated 2 times and B is repeated 3 times. All right, the next thing I'm going to talk about is SEQ. SEQ means, as you can imagine, it stands for sequence, right? So suppose you type SEQ from 2 to 8 in steps of 2, right? And this is what you will get. You see, it's a sequence of numbers from 2 to 8, and increment is 2 every time. So it's 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8, right? And if you say by 3, it will be this: 2 plus 3 is 5, 5 plus 3 is 8, right? And you can also increment by real numbers, not integers, like 3.5, for example. In this case, you only get these two because 2 plus 3.5 is 5.5. 5.5 plus 3.5 is 9, which is beyond the range. So you get only the numbers within the range from 2 to 8. Okay, and you can also have a decreasing sequence. So suppose you want the numbers from 5 to 2 decreasing by 0.5 every time. So you have 5, then 4.5, 4, 3.5, and so on, right? Okay, guys, so you can have a decreasing sequence too. And again, you can also use the length out command one more time. Like suppose you want to go from 2 to 8, length out equal to 6. Now, in this case, what happens is the following. You have numbers from 2 to 8, and there are 6 of them. There are 6, as you can see, there are 6 numbers in this. And these 6 numbers are equally spaced, as you can see. So 2 plus 1.2 is 3.2, plus 1.2 is 4.4, plus 1.2 is 5.6, and so on. So the length out determines the number in the output, and the numbers must be equally spaced. Another way of doing this is to define z like this, and then say sequence from say 4 to 14 along with z, right? In this case, you get a similar output, and you have 5 numbers here, so the output also contains 5 numbers between 4 and 14, and the output must be equally, I mean, the numbers are equally spaced, as you can see. So 4 plus 1.5 is 6.5, plus 1.5 is 9, plus 1.5 is 11.5, and so on, right? Okay, so this is another way of producing numbers that are equally spaced between two given numbers, in this case 4 and 14, right? All right, guys, you have any questions so far? So when you write 1 colon 4, it gives the numbers 1 to 4, whereas if you do this, it gives you the numbers 4 to 1, right? Any questions so far, guys? Are you okay? Let me know. I mean, please feel free to use the chat box to write any questions you guys have, please. All right, the next thing I'm going to talk about is summary statistics, right? All right, now, so let me go back to the website, the course website. You may recall this data set. I mean, I talked about this data in week 1. This is known as the Moses data, and it contains time values of time for different people. Okay. Now let me first read this data. So I will copy data equal to true, right? And let me call the data Moses. I mean, you can call it any other name you want, right? I just want to call it Moses, all right? And then once this is the data that I just read. So if you type Moses, you see the data that I just read. And if you type names Moses, it gives you the column that you just read, which is called time, right? So Moses $time picks the, excuse me, sorry, it is time. The Moses $time picks the column that you just read. So whenever I use the simple dollar, the sign dollar means it picked the column that you want to pick. In this case, there's only one column, so it's just $time, right? Okay, let me call this for short. Let me call this T, right? Now, if you want to do summary statistics like mean, this is the mean, right? This is the median. This is the sample variance. This is the standard deviation, right, and so on. And there's something called the 5 number, which I will show you in a minute. This is 5 number means the following. It gives you 5 different summary statistics of the data. The first one is the minimum, the second is the first quartile, the third is the median, the fourth is the third quartile, and the fifth is the maximum. So if you let me call the output FNS, right? I mean, you can call it any other name you like. Then if you type FNS, you see the 5 numbers again. Now, suppose you want to compute the interquartile range. Remember, from the lectures, you will know that the interquartile range is the difference between the third quartile and the first quartile, right? So IQR for this data set is 1.05. So this is the fourth element, which is this one, the third quartile. This is the second element, which is this one, which is the first quartile. Now, another way of summarizing data is to use the command called summary. And that gives these 5 numbers. The first is the minimum, the second is the first quartile, then the median, then the mean, then the third quartile, and then the maximum. So this output, it contains one more summary statistics than the output given by the 5 number command. This output only has 5 numbers, whereas this output has 6 numbers. So the additional number that you're getting here is the mean, is this one here, which is not in the 5 in this output, right? Okay. Now, another command that is useful to know is the quantile command. Remember, I talked about quantiles in the lectures, I mean, in the videos, right? Now, suppose you want to compute the quantiles of the data at 0.25, which corresponds to the first quartile, 0.5 corresponds to the median, 0.75 corresponds to the third quartile, and 1 corresponds to the maximum. Now, for the quantile command, you can have 2 different types, type 6 or type 7. Now, for this course, I will always use type 6. Okay, so if you do this, this is the output that you will get. So this is the minimum, this is the first quartile, this is the median, this is the third quartile, and this is the maximum. There's also one other type, which is type 7. It gives slightly different results because it uses a different formula. It uses a different formula from the one I gave you in the video. In the videos, the formula I gave corresponds to type equal to 6, right? Type equal to 7 uses a slightly different formula, which I did not give you in the video, right? And if you actually look at page 2, the bottom of page 2 of the tutorial sheet, it gives you the 2 different formulas, the one for type 6 and the one for type 7. But as I said, I will always use type 6 for this course, right? So you don't need to bother about type 7, okay? All right, guys, are you okay so far? Right, let me know if you have questions. All right, the next thing is about graphics. When, like, suppose, sorry, good question from Cameron. Please could you scroll up and to see why you use the data set, how you used it in R. All right, let me show you. This is the data set I read, Cameron. This is the, yeah. So I read, excuse me. This is the data set I read, right? I read the data from the Moses.txt, right? And I call the data Moses, right? And then this is the output of the data. And I'm interested in the time column. So when you go down here, I'm saying Moses $time, which is this data here, right? And so because I want to work out the summary statistics of the time data, I use this just for shorthand, right? Let me call the data T, right? So T is assigned the data Moses $time. And then I did the summary statistics for T. I hope this is okay to you. Does it answer your question, Camera? I hope so. But otherwise, let me know. All right. Okay. The next thing I'm going to talk about, guys, is how to open Windows and so on. Now, suppose you want to record everything that you're doing in R. One way to do that is to use the command Windows in brackets record equal to T, right? I'm not going to do that now, so I would just remove this command. Now, suppose you want to open a new window. You can use this command to open a window, right? Okay, you can use this command. So as you can see, I have opened a new window. Every window that is open has a number. So this window has number 2. Now suppose I open another window, which is this one. I hope you can see this. This is the window I just opened, and this window has number 3. So every time you open a window, you get a different number, right? Depending on how many windows you have opened, right? So you have, at the moment, I have opened 2 windows, window with number 2 and a window with number 3. Now, suppose you want to plot something, all right? So if you want to plot something in a certain window, then you have to set the window. So one way to do that is, suppose I want to plot something in device number 3, then you say device.set in brackets 3, right? And that will set device 3 to be active, so that whenever you plot something, it will appear in device 3 and not device 2, right? Okay, and suppose you want to switch off the window. If you want to switch off the window, then you say device.off and the number of the window. So as you can see, the device 3 has disappeared. Okay, now if you want to switch off device 2, then you say this. And as you can see, both windows have now disappeared, right? So it's a very, very, very easy thing to do. So these commands allow you to open windows and choose windows that you want to plot in, and also close windows, right? All right. The next thing I'm going to do is some more plotting. Now here I want to show you how to plot categorical data. Okay, the first thing I want to do is I want to create some categorical data. So this is the data that I talked about in week 1, you may recall. So this is the data with 5 different parties: Conservative, Labor, Liberal Democrats, UKIP, and other, right? Let me call this other, right? These are the 5 different parties, and let me replicate them and repeat each of these parties. So let me repeat 3: Conservative 369, Labor 314, Liberal Democrats 75, UKIP 118, and others 124. So this is the data that you get. So if you type Paul now, you see the data that I just simulated, right? Or just created, right? This is the data I just created, right? Now, the first thing I'm going to do is I'm going to convert this data into a factor. I mean, if you want to plot categorical data, it's useful to convert it into a factor, right? I mean, factor usually corresponds to categorical data, right? Okay, then you can use the table command to summarize a factor variable. So you see, this tells you like how many votes each party has got. And if you use the plot command, it will plot it will plot the categorical data that we just created, right? As you can see, each bar corresponds to the number of votes the party got. So the Conservative has got the highest number of seats or votes, and the Liberal Democrats has got the smallest number of votes, right? All right. This is a way of plotting a bar plot when you have categorical data, right? All right. The next thing I'm going to talk about is how to do a histogram. You may recall the Moses data. This is the Moses data that I talked about a few minutes ago, right? Now, suppose you want to do a histogram of this data. You just type this, and this is what you will get. Okay, I've got a question. In Charles, yeah. To add if you want to add a title for a plot, you can use the main command. Yeah, you can use like main, like say, suppose like this is a histogram, right? Then you see here that, as you can see, the title that I just added goes to the top of the histogram, right? Okay, yeah. You can add any title you want, right? Okay, in this histogram, the y-axis is a frequency column. The x-axis are the intervals. Now, suppose you want to convert the frequency into density. To do that, you need to use this command, frequency equal to false. So now if you look back at this, you see that the y-axis is now a density column and the x-axis is the same. Now, suppose you can also change the x-axis using the breaks command. When I say breaks, like, I mean this. Factor, yeah, the factor is basically a command that you can use like when you have categorical data. So when you convert something to a factor, it enables you to plot like a bar plot, for example. And also it enables you to summarize categorical data using the table command. You see what I've done before, Joe, like you need to convert categorical data into a factor before you can actually use the table command or the plot command, right? Without actually doing this, you won't be able to execute the table command or the plot command. So that's why factor is useful. I mean, factor is very useful. The factor command is very useful when you deal with categorical data, like the party data is an example of a categorical data, right? I hope you follow that. Okay. Right now, okay, back to the histogram. What I have done here, guys, is to change the x-axis. I don't know if you can see this. I changed the x-axis from using the breaks command. So here the intervals for the x-axis go from 47 to 51 in steps of 0.4. So the 0.4 here corresponds to the width of each bar, right? So each bar here is of width 0.4. And the interval starts at 47 and ends at 51. Right, so that's how you can choose your own x-axis for a histogram using the breaks command. So, for example, you should type 46.8 to 50.8. This is what you will get. See here, the interval starts at 46.8 and ends at 50.8, and once again each bar is of length 0.4, right? All right, the next thing I'm going to talk about is box plot. Box plot, to do a box plot, you just use this command, right? Okay, so you see you see this, right? So here there are, okay, the middle line is the median. This line here is the first quartile, and this line is the third quartile, and this line over here is the lower adjacent, and this is the upper adjacent. And the lower fence and the upper fence are there, they are beyond the plotting region, the plotted region, right? So you need, I mean, I talked about all this in the, I think it was week 1, I think. I talked about what the lower fence is, what an upper fence is, what a lower adjacent is, what an upper adjacent is, and so on, right? Okay. Right. The next thing I'm going to talk about is some more data sets. So let me go back to the website. Let me, we're done with this runners data set. All right, this is a runners data set. As you can see, it has 2 columns. The first column is the PMOL. The second column is a group column. PMOL corresponds to the concentration of a chemical found in your body. And the group corresponds to whether the runner was successful or not successful. That means collapsed, right? Okay, so let me read this data. So go back to R and paste it. And so I'm going to use the read table command as usual, right? And let me call this runners, okay? And as usual, I'm going to say header equal to true, right? Okay, now you should type runners. You will see the data that I just read, okay? And if you type names runners, it gives you the names of the 2 columns that I just read. So we are interested in both columns of data, right? Now, suppose you want to do a box plot of the concentration level versus the group. Remember, the group name can be either successful or collapsed, right? Okay. What do you type at the end of the read table? Oh, what did I type? Yeah, I just type header equal to true, sir. Header, I just type header equal to true, Cameron. Yeah, that's I always type that because most data sets have a header, right? Okay. Yeah. All right. Now, suppose you want to do a box plot of the concentration level, which is PMOL, right, versus the group. The group can be either 2 levels, right? Either successful or not successful. And this is what you see, right? This is the, I don't know if you can see it clearly. Yeah. So you see 2 different box plots. The first one corresponds to the group which collapsed. That is the people who did not complete the run, the race. And this corresponds to the people who completed the race, right? As you can see, the concentration level for the first group is higher compared to the second group, right? And also the variability, remember the variability is measured by the length of the box or the width of the box, the length of the box, yeah? So the variability is a lot higher for the first group compared to the second group, right? So these kind of plots actually enable you to compare the location and also the variability of the data for when you have 2 different groups, right? Okay, right. The next thing I'm going to talk about is, all right, let me type the data set. As you can see, the concentration level goes from 29.6 to 414. This is a big range, right? Now let me pick a certain subset of the data where the concentration level is greater than 100. So I'm interested in the concentration level being greater than 100, right? So now if you want to pick that subset, then you Can you guys, can you mute, please, guys? I hear somebody talking. Can you please mute? Thank you, guys. Now, if you want to pick the subset that corresponds to the high concentration, right? This is the command that you will use, right? And then you say runners high, and you see that these are the people that have concentration greater than 100, right? Okay, right. Now, if you want to summarize, if you want to summarize these people, then you see that you will see this is the summary that you're getting. So you have seven runners, all of them collapsed, right? All of them have concentration greater than 100, and none of them were successful, right? Zero. None of them were successful, right? Okay, so in this case, there's no point having the second group because there's nobody in the second group, right? So one thing you can do here is to remove the second group because there are none. There are no one there, right? So one way to do that is to use the command drop levels. So it drops the levels that has zero frequency, right? All right, and then if you retype the summary command, you see that, oh yeah, Simon, I got a comment from Simon. Yeah, that's a very good question, Simon. Yeah, the summary command here applies to categorical data. This is categorical data. That's why you are getting this output, right? I mean, runners group is a categorical data, Simon. Whereas the variable, when I typed summary in brackets T, this is what you got. Because T is a numerical data, right? T is a numerical data, whereas this one is not numerical, it's a categorical data. So that's what you can, so the summary gives you this output, right? So you see the distinction between the two. All right, the next thing I'm going to show you is how to do a scatter plot. Now suppose you take X as the numbers from -5 to +5. So X are these numbers, right? Okay. When I used the summary, it gave me this: length, class, mode. I don't understand what you're saying, guys. What do you mean? If you use the summary for the, okay, let me show you. If you use this is what you should get, right? Yeah, this is what you should get. Whereas if you use it for this, it means a different thing, because here runners high is partly numerical and partly categorical, right? It has two parts, as you can see. Runners high is a data set that has two parts. It has two columns. The first column is numerical. The second column is categorical. So when you say summary like this, it gives the numerical summary for the first column and the categorical summary for the second column. So depending on how many columns the data has, right? You see what I'm saying? Yeah. Okay. All right. Let me return to X. X is this data from -5 to +5. Now suppose you want to plot X versus Y, which is say X squared, and this is what you will get. And I'm sure you've done your math. This is what is known as the parabola. I'm sure all of you know that, right? Now, suppose you want to join the points, right? Then you say type equals to L, not 1. Now, here we have joined the points by line. So here, not to be confused, here this means line, not 1, okay? Now, suppose you want to change the color from black to some other color, like say red, for example. All right, so you say color equal to 2, which corresponds to red. And you can change the color. So if the color equal to 3 corresponds to green and so on, right? Okay. Now suppose you define X as a sequence from 0 to 5, the length of 100. So this is what you will get. So this is a sequence of numbers between 0 and 5 of length 100, and they must be equally spaced, right? And then if you type plot, type equal to L and color equal to 2, this is what you will get. So this is a part of a parabola on the x-axis, on the positive x-axis, right? Now, if you want to plot something on top of on the same graph, you can use the lines command. So this command here will plot a cubic, right, with color equal to 4. So you see this. So the one in blue is a cubic polynomial, and the one in red is it's a quadratic polynomial. All right. So they are both plotted on the same graph, as you can see. And you can even add one more if you like. Suppose you want a quartic polynomial. This is what you get. So the one in purple is a polynomial of order 4 on the same graph. All right. Okay. So that completes the tutorial. Now we have 3 exercises to do. So can you guys go to page 7 of the tutorial sheet? The first exercise is about a simulated data set. So let me go back to the website. Sorry, excuse me. What am I? Excuse me. So this is the simulated data set. So I'm gonna read this. So let me copy it. Paste it here. So I'm gonna read it with header equal to true as usual. So read dot table in quotes, right? Right, this is what you read. So you should type simdat. This is the data that I just read, right? Okay. Now I'm interested in the second column. By the way, if you want to look at the names of the column, you can use the command names, right? So this gives you the names of the columns that I've just read. Now I'm interested in the second column, which is X. So I say $X, and let me call this XS, right? So I want to find the summary statistics of this data. So for example, the 5-number summary will be this, right? So the first number is the minimum, the second is the first quartile, this is the median, third quartile, and the maximum, right? So let me call this, for short, let me call this FNS, right? Now, I can compute the IQR as the difference between the third quartile and the first quartile. So your IQR is 2.64777. Another way of summarizing data is to use the summary command, as I mentioned before. So this gives the same numbers as earlier, except you have one additional summary statistics, which is the mean, right? So you have the minimum, first quartile, median, mean, third quartile, and the maximum, right? And you can also compute the variance. This is the variance. You can also compute the standard deviation, right? Now, if you do a box plot of, this is what you will get. Right, so this is the box plot of the data that we just read. As you can see, the median is not exactly halfway between the first and the third quartile, which means that the distribution is not exactly symmetric. It's kind of skewed, right? Because of this, right? Because it's not halfway. I mean, if it is halfway between the two quartiles, then it will be symmetric. It will be a symmetric distribution. Now, to see this more, you can use the hist command. if you use the histogram command, you see this. This kind of shows you that the distribution is not symmetric. It's kind of skewed, right? I mean, I talked about you should go to week 1 material. You should go to week 1. I talked about what I mean by there are two kinds of skewness. There's a negative skewness, and there's a positive skewness, and also there's also symmetry. So if you look at week 1 videos on week 1, you will see those. I talked about them. All right, and you can change here the frequency to F. That will produce a histogram with the density column instead of the frequency column. And you can also change the x-axis to what you want. So for example, if you say breaks is a sequence from 9 to 16.5 in steps of 1.5, this is, sorry, I made a mistake. From, what did I do? From breaks. What mistake did I make? Breaks equal to, not being clever today. Breaks equal to sequence. I don't know. What? I'm trying to see break. .5, 1.5, 9. I don't know. I think maybe. Let me see what it says. Is this? Yeah. From 6. Yeah. Sorry. It should be starts from 6. I think. Yeah. You're right, sir. Thank you, sir. Thank you, Charles. Yeah. All right. So you see, it starts from the intervals start from 6 to 16.5, and the length of each rectangle is equal to 1.5. Thank you, Charles, one more time. And you can also change this to as you want. Say 6.25 to 15.25 in steps of 1. So you will have this histogram. So here the lower limit is 6.25, the upper limit is 15.25, and the length of the width of each rectangle is 1. All right. So you can use the breaks command to change the x-axis as you wish. And these histograms show once again that the distribution of the data is not symmetric, right? It's kind of skewed. All right, the next, so that completes exercise 1. Any questions on exercise 1 before? Guys, talk to me. Do you have any questions on exercise 1 before I go to the next one? Okay, thank you. All right, exercise 2 is about another data set, which is this one. All right, this is the GISA data set. It has 3 columns. I don't know whether you've been. This data set relates to the Yellowstone National Park in the United States, and this is the day of the eruption. This is the duration of the eruption, and this is the interval of the eruptions. And I am interested in the second column, which is the duration of the eruptions. Right, there are 222 such eruptions in that national park. All right, so I'm going to read the data using header equal to true, and let me call this GISA. I mean, you can call it whatever you like. You don't need to follow the name I give. Right now, now if you type names and the name of the data that you call, then it gives you the names of the interval that you just read. So the day column, the duration column, and the interval column. right? And I'm interested in the duration column, so I pick $duration, and let me call this XD for short, right? Now I want to find out the summary statistics of XD. You type this. So you see here that the shortest duration is 1.7, the longest is 5.2, the median is 4. And you can also compute the variance using this command. You can compute the standard deviation using this command, and you can do a box plot using this command, and this is what you get. Here, as you can see, the box plot is nowhere near being symmetric, right? Because as you can see, the median is very far away from being symmetric, right? Okay. Now, in this case, it is useful to do a histogram command. So it's useful to do a histogram. Okay, so let me do a histogram. This is what you get. Now, this is what you get. Now, if let me increase the breaks, the number of breaks to something larger using the breaks command is equal to say 16. And this is what you get, right? As you look at this histogram, you will see there are two modes. You know what a mode is, right, or not? You guys not? I mean, I hope you know what a mode is. Mode is the point giving the largest density value. I'm sure you guys done this before, maybe in your. So in this, if you look at this picture here, you see there are two different modes. There is a mode around here, and there is a mode around here. The mode around here corresponds to short durations, I mean, of eruptions. And the mode around here corresponds to long duration eruptions. So the distribution is basically a mixture of two different distributions, right? One corresponds to short duration eruptions, the other corresponds to long duration eruptions, and it's a mixture of the two, right? Okay, and so it's nowhere near being symmetric, right? You can change the x-axis as you want. Say, for example, if you want it from say 1.5 to 5.5 in steps of 0.25, this is what you will get. So here the x-axis goes from 1.5 to 5.5, and each rectangle is of width 0.25, right? And here you can change this to 0.5, it will look like this. If you change this to 0.75, it will look like this, right? In all cases, what you see is a mixture of two different distributions, right? One corresponding to short durations, the other corresponding to long durations. All right, so that completes exercise 2. The last one is, I know I'm running out of time. The last one is exercise 3. If you give me a couple of minutes, I will finish exercise 3. All right, I hope you're not too hungry if you're in the UK. So I haven't had my lunch yet. So, all right, the last exercise corresponds to this data set, which is an anorexia data set. Anorexia is a kind of a disease or something. I don't know much about it, but it has four columns. The first is the case column. The second is it's a pre-weight. Pre-weight means the weight before the treatment, and this is the post-weight, which is the weight after the treatment. And the last column is the treatment column, and there are 3 different treatments. The question in this exercise is to determine the treatment that is most effective. In other words, determine the treatment that makes the largest difference to the weight before and after the treatment, right? So to do this, I'm gonna read the data first, right? I apologize for running out of time. I hope you don't mind. Okay. Okay, so let me call this data anorexia. Oh, sorry, what did I do? I forgot to put a quote here. Okay, all right. So this is the data that I just read. Now, if you want to look at the columns of the data that you just read, these are the 4 columns. Now, as I said a minute ago, I'm interested in finding the treatment, right, that gives the most, that is most effective. In other words, the treatment that has had the biggest change in the weight, right? Okay, so let me call for short, let me call treat. Okay, treat is a short name for the treatment, right? And I'm interested in the differences in weight before uh, after and before the treatment. All right. So this is the differences in weight after and before the treatment. And I need to define now the differences in weight corresponding to each treatment. So this one, sorry, excuse me, this gives you the differences in weight for treatment 1. And this gives you the differences in weight for treatment 2. And this gives you the differences in weight for treatment 3. Now, I want to compare these 3 objects. So what I do is to use the summary command. So these are the summary statistics. Oh, sorry, what did I do? I have done something stupid here, I think. Excuse me, I think pre-weight, post, this should be post-weight, not POST. All right, let me repeat it now one more time. Excuse me for this. I just made a silly spelling mistake. All right, now, all right, these are the summary statistics for the first treatment, and these are the summary statistics for the second treatment, and these are the summary statistics for the third treatment. As you can see, if you compare these numbers across the 3 different treatments, you see that the numbers are the largest for treatment number 3. In other words, you see the median is the largest for treatment 3. The mean is the largest for treatment 3. The third quartile is the largest for treatment 3. And the maximum is also the largest for treatment 3. So among these 3 different treatments, the one that has the largest effect is treatment 3. Now you can see this more clearly. You should do a box plot. You should do a box plot of the differences in weight versus treatment, right? This is what you will see. See, this plot clearly shows what the treatment has made, right? The effect it has made. Treatment 3 has the largest differences. Treatment 2 has the second largest, and treatment 1 has the smallest differences. So treatment 3 is the most effective, treatment 2 is the second most effective, and treatment 1 is the least effective in terms of the difference it made to the weight before and after the treatment. All right, guys. So that completes the exercise 3. I'm sorry for running out of time. Any questions on this, guys, and on the tutorial? So it also completes the tutorial. You guys okay? Hello, guys. Thank you, guys. So have a great afternoon or evening, depending on where you are. I will post the video of this tutorial. Give me about half an hour or so. I will post them in YouTube and also post them on the UOM website. Okay, so you'll be able to see them again. Okay. All right, guys. So have a great evening or have a great afternoon. I will talk to you soon. Right. And for any questions on this course, you can contact me for 24/7 by phone or email or Skype or Zoom. Right. So feel free to do that. Have a great day, guys.